Hi, this is always Eclectic Stacy with 5-Minute Chemistry, where you learn chemistry concepts and see examples in 5 minutes or less. We're still in our ionic compound series, and today we're learning how to take a balanced ionic compound and converting it to the proper name. And this one example is CuO. Soon to see you over there. Have a great one. Welcome back to Always Eclectic Stacy. Today we're balancing CuO into a name. So we're taking the compound CuO and we're going to convert it to the name. The first thing we always have to do is to determine whether it's an ionic compound or a covalent compound. And the way you do that is you look at that first element, Cu. It is a metal. It's actually a transition metal. And the second element is a nonmetal. So we already know that it is going to be an ionic compound. And so we can underline the metal and then underline the nonmetal, because I like to do them in separate colors. And we have to determine, and I already stated it, but is this first element a transition metal? Or is it one of those metals like tin and lead that act like a transition metal? And the answer is yes, it is, which means you have to determine the charge of it, because you have to put the charge of transition metals in Roman numerals. And that is always based on your anion. So our anion, you can just name, it's oxide. Remember, you do your root of the element. So O, the root is ox, and then you add I, D, E. And we know Cu is copper, so we can write copper under it. And you put in where your name's going to be in the Roman numerals. Now, there's several ways of doing this, and I'll show you more than one way. So oxide is O2 minus, and copper is Cu, but we don't know the charge because copper can be copper 1, 1 plus, copper 2, 2 plus. So we're not sure what it is. So we can look at it like this. Okay, copper plus oxide forms CuO. Okay, and we could look here and see that there are no subscripts, meaning there's one of each. So that means one of each makes it zero sum, meaning no charge on the compound. Well, the only other charge that would be a zero sum for oxide, so 2 minus, copper would have to be 2 plus, because 1, 2 plus 1, 2 minus does equal CuO, so it ends up being copper 2 oxide. But the other way you can do that is something called the reverse LCM. I'm going to show you what that looks like. So you put Cu over here, just like you would with an LCM, and then you put oxide here. And you're going to set up the LCM in the exact same way. So that first line, or this first column, is going to be your charge. And we do not know the charge of copper. We do know the charge of oxide is 2. And remember, for this one, we're just worrying about the numbers, not the charge 2 plus or 2 minus. It makes it slightly easier. That times the subscript, and the subscript here is 1, because you've written it one time, gives you your LCM. So 2 times 1 is 2. And this is always based on either your anion or your polyatomic anion. This is never based on your positive ion. So copper, and we know there's one of them, equals, and remember the LCM has to be the same, so I just take this 2 and I put it up here. So my charge number is going to be whatever makes this true, and that's going to be 2. So we still end up either way, whether you're doing it this way or this way with copper to oxide. Thank you so much for watching Always Eclectic Stacy. If you like this content, please do not forget to like and subscribe and check out some of our other videos. Have a great day.